So, we're going to continue what we started the other day, kind of talking about key features of the quadratic curve, okay? So, these things. Get out a sheet of paper, draw two different curves. Draw your x and y axis, all right, and two different curves, and explain how are they different, how are they the same, and I want you to use some of our mathematical terms that we have defined and that we've been using in the past few days. Okay? So just take a few minutes, get started. I'll walk around the room, kind of figure out what you're doing, all right, and describe how they're different, how they're the same. Similarities and differences. All right, go. That's good.
Correct.
Say a normal graph. What do you mean normal?
Normal by just regular parent function of x.
Okay, parent function. Great. All right.
No compression or stretch. Also, it's not negative. It's facing upwards.
All right. It's opening up. Good.
The second one is facing down. We could make the a in the ax squared plus bx plus c negative. I mean, otherwise, they're both the exact same except for the way they're facing. So it's just one similarity.
Great.
Or difference.
All right. First one. First equation there. What'd you say?
Standard.
It's in standard form. All right. The first one's in standard form. What's something you know about that equation? It can be factored. Okay. It can be factored. Great. What's that, Zach? Get your y-intercept. All right. So when we're in standard form, we can determine what the y-intercept is. Great. Okay. So the second equation up there, what form is that? It's in factored form. Okay. So when we're in factored form, what's a key feature we can pick out? And you can tell what the roots are. All right. The two roots of the function. Okay. All right. Our last one there, what form is that in, Brandon? It's in vertex form. Well, and vertex form, it's easy to tell. The vertex. All right, great. What was that?
They're only used once.
Yes, they are only matched once. All right. Have you made any matches yet? All right. What was the first one that you made?
A.
A?
Yeah, and it matches graph
With graph what?
9.
All right. What made you decide that?
It matches graph 9 because we looked at the equation and it's not a reflection, so it's open.
Okay, great, great.
And the y-intercept is negative 35.
All right, the y-intercept clearly labeled on the graph at negative 35. Perfect, great, awesome. Okay, so what have we matched up so far? Okay, great. Can you explain why on one of them? Just pick one out for me.
We got the standard form of it,
The standard form, okay.
and it had a y-intercept of negative 35,
Excellent.
and graph 9 was the only one which had a y-intercept of negative.
Okay, out of all of the graphs, it was the only one that had that y-intercept. Perfect. That is good. Good, good, good.
Roots of negative 4 and negative 4.
Hey boys, where'd you start?
So we've got 2 so far. We started out with G because it has no roots, which means there's
Show me the card.
G. No, it says it has no roots, and this is the only one that didn't have any x-intercepts.
Excellent. Excellent.
So, bam. Then we got a second one, and it's just a parent function. That one has no points but the vertex, which is 0, 0.
Very good. Very good. All right. Right, you're ruling out some ones that are very clearly
Easier to find.
okay. Good strategy. You were able to figure out that it was 16 for the y-intercept. And what else? What other equation? Show me that card again. All right, so what's that second equation?
Factored form?
It's factored form, so what are the roots?
4 and negative 4.
What are they?
4 and negative 4. Or 4 and 4.
4 and 4. They're both 4. What's that? They're both the same. What does that mean? What?
Do you have to multiply them?
So there's no.
All right, show me the card.
So Carfax.
Whoa.
Carfax.
So that says it has no roots, which means there's no what? There's no x-axis?
X-intercepts.
There are no x-intercepts. All right, look at all of your graphs. Does that have an x-intercept? All right.
All of them do. And it opens up.
Well, let me show that card. Show me that card.
No.
All right. Now, look at it. Does that have any x-intercepts? No. Ah, excellent. Hold up those two cards so I can get a closer look at
So
it.
what I noticed was this one right here
All right.
intercepts at twice as early as this one. So
All right. Okay.
I was wondering, like, so this is a stretch graph.
Yeah.
And what's the equation for a stretch graph? Like, what's the difference?
All right. Let's look at those equations then. All right.
That's what I was trying
What tells you the stretch or compression of a graph? All right. We're talking about quadratics, right? They're all squared, right? X squared, they're all squared. But what's going to make a difference of one being stretched out or wider or narrower than the other? Yes. Excellent. So work through that and you guys still working on your matches? How many you got left?
Well, we got them a lot. We got them mixed up.
Okay, you got some mixed up. Just checking over it, okay. How you doing, girls? Good. All right. You got most of them? Or you got a few of them? Four's good. All right, so tell me about one of them. Okay, so you chose the wrong thing first, but then you... Good. Yeah. Trial and error. Right. Okay. Good. Guys working on filling in the equations?
Yeah.
Okay. Why did I say you could fill them in without using algebra?
Because you can look at the graphs and it tells you stuff like the vertexes and
Like the vertex, what else?
x-intercepts,
X-intercepts,
y-intercepts,
y-intercepts, and that'll help you fill in the,
equations.
or any missing information in any of them. Okay, good. What's that? What can be? It can be. You're correct.
Is it always going to be? No. It's deep in thought. What are we looking at?
I'm just trying to figure this one out.
Which one?
Find the vertex. I'm given it's 4. Oh wait, it's 0, 4. My bad.
What's wrong?
Oh no, just I was thinking too hard and missed an obvious answer.
Okay.
It's 0, 4.
That's the vertex?
The vertex is 0, 4 because it's on the x-axis. 0.
Which,
Wait, no. 4, 4, 0.
4, 0. Okay,
It's
there
on
you
the
go.
x-axis.
Okay. Right.
Too hard. Thinking too hard.
That's what we're doing?
But you're thinking. That's good.
That's what we're hoping.